Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science.
Hello and welcome to Quarantine Content with my Python heroes, ctds.show. In this episode, I interview Chief Data Scientist at More Consulting, Ian Ozsvald. Ian is an author of High Performance Python. It's a book with O'Reilly Publishing that he's authored and has been involved in the field for over 2 decades now. We, of course, talk all about his rich experience in Python and in data science, broadly speaking, in AI, very broadly speaking. Ian shares a lot of insights that he's picked up along his journey while working on so many rich projects, so many projects across different consulting tasks, different consulting missions that he's taken up. We also touch upon his book, who should read the book and what will they get out of it. Ian also broadly shares many amazing advices that he has learned over all of these years, and I think this is one of the most insightful interviews for anyone who even uses Python, at least for even 1 hour of their day. Ian also runs his consulting called More Consulting, MOR Consulting. If you'd like to check it out, please go to the website moreconsulting.com or find it in the show notes. And definitely do check out his talks or his blog posts, also linked in the show notes. Without further ado, here's my conversation with Ian Ozsvald. Please enjoy the show. I'm really excited and very honored to be talking to Ian on the call. Ian, thank you so much for joining me on the podcast.
It's great to be here. Thank you very much for having me along.
So I'm going to pull something that you do with your audience. I'm going to ask you to smile and wave just so that I can take a screenshot for the thumbnel. Can you do that?
So I'm very happy to smile and wave. Yes, that's something that I do in my videos. And actually when I'm on stage at events, I will always ask my audience to smile and wave.
I think that's awesome. I got a few pretty good pictures. Otherwise, it's always a hassle to pick the right thumbnail. So I want to start by talking about your interest in AI. I know AI, broadly speaking, you did a master's back in the 90s. Why did you get interested in AI at that point of time, broadly speaking? And how do you think the landscape has changed since you've been involved?
Simon, I think you're the first person to ask me why did I get interested in AI in the 90s? And it's never occurred to me that was a question because I've always been interested in AI. I was building robots out of Technic Lego when I was about that big. I was thinking back to it when your question prompted me to think back. On my Commodore 64, I was using light sensors and the speech cartridge to talk to the people that they walk past, or to my family as they walk past in the corridor. I had the robot plugged in there. I think I tried several light sensors to do some crude like pixel detection of like the size of a shape. I used to write ELIZA chatbots and Shroud solver. That was all on my Commodore 64. I did some similar things on a Spectrum. And then I graduated to an Amiga and I could do some more advanced things. And I had Game of Life and then cellular automators, simple neural networks. Simulations of evolution with evolutionary computation and little environments and bugs running around. And it never occurred to me that wasn't a normal way for a teenager to spend their time. And it just turns out as I got older, I realized that no, that wasn't entirely normal for some of us. It's quite a normal thing, but for most
it is now. It's more
not
now.
the normal thing. And yeah. So yes, so it never occurred to me to get interested in AI. I just always have been in that field. Somewhere between high performance technical computing and artificial intelligence, kind of the exploitation of information at a very low level. That's always been my bag.
Okay. How do you think the landscape has changed? You were coding robots with Commodore 64. Now there's Arduino. Do you envy the boomers?
When you say the boomers, who do you mean by the boomers?
I think the Zoomers is the right word.
Oh, Zoomers. Sorry, Zoomers. Right, not the 60s boomers. Yeah. No, that was my hearing. Do I envy the Zoomers? No, I try not to envy anybody. Certainly, I have no regrets about where I am in time and what is happening around us. I figure time's always interesting, right? There's always interesting things going on. Some things are easier now. We have lots of compute power. We have lots more data available. You don't have a 1200 baud modem to be trying to pull your data down when you don't even know if you can get hold of data in the first place. The free flow of information is much faster than it used to be. You can get research papers anywhere. When I was dialing up to various internet services and the internet, when I had access not to say FidoNet on the Commodore 64, but to the internet proper, and Telnet protocol and Gopher, and I could see research papers before I went to university. That was amazing, and it was very difficult to get hold of these things. Libraries made them either expensive or impossible to get hold of, sadly. And now kind of the world's knowledge is available for free, but also it's kind of overwhelming at the same time. So to me, that's a bit terrifying. So your interest could be split in so many ways. For me back then, I had a couple of things that seemed cool. I was ignorant to everything else, so I just did the things that I thought were cool, and I was happy. So certainly no regrets and no negative emotions to where we are in time. I figure, hey, it's all available. If you're interested, there's lots of stuff you can go and do. So great, go and do it. And you can do it so much faster now without worrying about having to code algorithms up in some horribly heuristicy, cheap and nasty way just to try to make it run in any kind of useful amount of time. Now we've got really fast resources to use, and that's amazing.
Absolutely. This brings me into an interesting segue, an easy segue. You've actually written a book about high performance for Python. Why is that important? Why not just use C++ or something that's way faster? Why is that important for data scientists? To the extent that you wrote a book about it.
Absolutely, yeah. So in fact, I have the book here. And in the background, there's the picture from O'Reilly for the first edition, and this is the second edition. And I'm kind of, whenever I do like a video thing, I hold it up because I'm really proud, because due to the pandemic, we can't have physical events, so I can't discuss the book with anyone. So look, I really did write it. Look, there it is. It's all there. There's lots of pages, because I can't show it to anyone. I can't go and discuss it.
I have a digital copy on my Kindle.
Right. Excellent. I'm very glad to hear that. So I can tell you the story of why I wrote that. It's a slightly convoluted story. I wrote it 7 years ago. Prior to that, actually, I wrote it 6 or so years ago with my co-author, Misha Gorolik.
So that was the first edition.
That was the first edition, and we wrote the second one together as well. Prior to that, I gave my first ever public talk at a conference at EuroPython in 2011. So that was 9 years ago. And I gave a 3-hour tutorial on high performance Python, so the same subject. I'd never taught before in public. I didn't know what to expect of my Python audience. I was terrified that they would all know more than me. Of course, that imposter syndrome is always a thing. So I crammed so much of my experience. I crammed 10 years of experience into that 3-hour tutorial. And then my students left like zombies because I just packed their brain with too much knowledge. But I was really happy to give back. So I spent many years building up part of my career, both running my own business and being employed, using the free tools and free algorithms, all the free stuff that's out there. And I wanted to share back. So I gave this tutorial. I thought it was very important to give back. And I knew that I really enjoyed my high performance subject. I was frustrated at the time. The only two sorts of groups that used high performance Python would either be, say, hedge funds, big financial firms, and I wasn't so interested in that domain back at that time, or university groups, and there was no chance to consult in those university groups because there was no money, so say physics research groups. So I had people doing work that I thought was super interesting, but I couldn't consult with them, and I was running a consultancy, or companies that I was just less interested in that domain at the time. So I figured, hey, maybe I can wrap up some of this work and give it away, and then I can move on to some other domain that interests me, which was the resurgence of artificial intelligence at that time, and particularly machine learning. That this is 10 years ago was becoming a bigger thing. Support vector machines had been a big deal. This was early decision trees and some of the extension work there back before neural nets became a whole new big thing. And I was getting really very interested in this game. So I figured, hey, I'd write this up and move on. O'Reilly said, do you want to write a book? I said, sure, I want to write this book. And they said, well, you can't. We've already got 2 authors writing this book. Ian, you can write any other book, but you can't write high-performance Python. I said, no, there's only one book that I want to write. It turns out one of the authors had to leave the project. And so Misha Gorolik, the other author, said, hey, Ian, you know this subject. You've been teaching it. Should we collaborate? We agreed, and we wrote the first book. And at that point, we'd never actually met. So we had to collaborate from the US to the UK, having never met. We just had lots of phone calls. It turns out we collaborated well. That was good. And we actually only met physically, I think 3 years ago. Misha was in the UK in London for a conference. I was running my PyData London event. And so we got to meet up for the first time and actually meet face-to-face as co-authors. And then we agreed to collaborate on a future version of the book as and when. And O'Reilly said, look, Python 3 is a big deal now. The book was written for Python 2.7. Would you be open to an update? We agreed. And so that's why we worked on the second edition of the book. And we can chat about that, I guess, in a minute. But to your other half of your question, why not something like C++? Well, that's to me, that's a very easy one. I used to be very proficient in C++. And in the first company I worked in for 5 years, I headed up the productionization of PhD research code written in, say, MATLAB into C++ with Microsoft Visual Studio with a group of 5 colleagues in an AI research firm. That was my first proper job. And so I took charge of this team, and we got really good at using C++ to code up our algorithms from this slow but clearly very expressive tool called MATLAB that was expensive, and you couldn't really turn it into proper industrial solutions as some of the clients wanted. They wanted C code. So fine, we would work out this C version, and that was brilliant. But whenever I did any research code, I found that I had to write lots of lines of code, which was great. I could do my type checking. I could check everything was inheritance based. I could write really good, clean code, but it was quite slow to develop new ideas. One day, one of my French colleagues said, look, Ian, we need you to work on this SAX parser for some HTML that we've got for a text processing problem for some machine learning. We've written a prototype in Python. We'd like you to take it on. And I said, oh, what, Python? This is like this horrible, weird language that no one uses. I've checked in the bookstore. There's hardly any books on it. It's interpreted. I mean, interpreted's bad, right? I've got my beautiful C++. This is amazing. We should be using C++. They said, look, just don't rewrite the script. Just use the Python language that we've done. We want to understand the end result. Maybe you could learn some Python and try to extend it. So I picked up this messy script, had a look at it. Oh, good grief. And I searched the internet, and there wasn't a lot of Python resources, but I learned a bit of Python. And by the end of that day, I was parsing my SAX code or SAX markup and getting out the results that the team wanted. And I sat back and thought, oh, if I was writing this in C++, I wouldn't have gotten this far in one day. And yet I'm leading a team after 5 years in C++ for a whole bunch of this kind of high performance work. And actually I'm more highly performant as a developer researcher learning Python on day one than I am after 5 years of my preferred language for this particular task. And that's one of those little light bulb moments where I thought, well, hang on a minute. If I have tight loops of numeric code, maybe I could write C++. And maybe for everything else, I need to be using a more expressive language, like the researchers with their MATLAB. Maybe I'll adopt Python. And I started with Python, and that was what, 13, 14 years ago? I've never looked back. So that's it, and I'm a complete Python convert. It's not the best language on the planet, but it happens, one of the arguments for it is it's the second best language for all the tasks. So it happens to be useful everywhere. And, that it gets out of my way, it lets me do my thing. I'm very happy.
I would completely agree with you on that. But if we can maybe quickly talk about the contents of the book, and I would love to know, there's this interesting initiative by the Rapids team. I'm not sure if you have any thoughts on that, which is just take everything that is already there on the CPU and put it on the GPU. What are your thoughts on that?
So I know a tiny bit about Rapids, but not enough to comment on it. So I won't talk about Rapids. I do have some opinions on GPUs, and I guess I can touch on that in a moment. As for what's in the book, so the first edition was written when Pandas was young. So there was no Pandas content in the first edition of the book. That was obviously an oversight. And the first edition was written when I'd spent 4 years working on GPUs with a physics firm. And I'd read at the time, the 2 books that were available for GPU programming. And I was writing my hand-tuned CUDA cores on my NVIDIA GTX 480 on a custom-built PC in this physics research lab. And it was amazing. I was getting these 10 times or 100 times speed-ups on my GTX 480. It was amazing. But nobody else in the company understood this code that I was writing. And I was writing a mixture of Python and PyCUDA as a wrapper around lower-level CUDA code. And it was amazing and fast, but no one understood it. So the likelihood that this code would survive me leaving the company was very low. So it was a brittle piece of code. And then the next generation of CUDA cores came out, and I realized that all the optimizations I'd written were not going to work. So I'd have to learn new stuff. And my colleague at the time, or my co-author, Misha, he agreed with these observations. So in the book, we also, in the first edition, we also said, GPUs are amazing, but really hard to program. So you shouldn't use them, avoid them. That was also clearly a bad call. So the second edition of the book fixes both of those points. Misha wrote a whole new section on PyTorch and the use of GPUs, and he's been using them for years, both on deep learning, but also for speeding up array-based computing.
Are you personally team TensorFlow or team PyTorch?
Say again, please?
Are you personally on team TensorFlow or team PyTorch?
Oh, right.
What side are you on?
I'm personally agnostic to both. So the reason is Misha uses GPUs, and so he does a lot of work with them. He's got some personal choices. He covered PyTorch in the book. Generally, I don't tend to use GPUs. We can use GPUs for some parts of machine learning. I tend to work a bit earlier in the data science world. I'm all about raw information and human need, and accepting that the raw information is probably really messy. It doesn't have what we want necessarily. The business process doesn't record the data that we need. So how do we combine these two things to get some kind of answer out? Often machine learning gets used there, but I find that I get involved in tabular data and smaller data sets, maybe millions of rows, maybe hundreds of columns, but not the kind of thing that needs deep learning, the kind of thing that needs a good XGBoost model with some really clear explanation about the features. And that even those models, they can run faster on GPUs, but in the many mixed environments I work in, having a CPU or having a 4-core CPU, that's good enough for the kinds of work that I do. So I don't get too involved in the GPU side of things, whereas my co-author does. And I don't know which camp Misha would be in, but I know he's a big believer in PyTorch. And I'm pretty sure he's used both sides of the others. And, they TensorFlow and Keras and Facebook solutions, they're all lovely and interesting. They all cover different aspects of the world. They give us some really good tools. So there's a nice mix of tooling out there. I would not be religious about any of those if I went down those particular routes. So for other bits in the book, we've got a whole bunch of NumPy. We've got a big section on pandas now. I wrote a whole chunk on that, and that's come into some of my public talks that I've given this year. We've got Misha's written a section on asynchronous programming, updating the entire async chapter that we had before. We've got some inclusion of JobLib, which makes parallel computing really easy to replace the multi-processing module that's built into Python, which nearly makes it easy, but isn't very cross-platform, whereas JobLib is cross-platform. We have got the GPU section. One thing that I'm super proud of is the extra essays that we've got in the Lessons from the Field chapter. So in the first edition, we gathered opinions from a bunch of people that we knew that we respected and had them write 4 or 5 page sections. And then we've got 4 more that have been added in this time. So Soledad Gali, Linda Uruchertu, Valentin Haenel, and Vincent Warmadam have added some lessons on how to be performant. So how to solve the right problem in your business, how to solve the right kind of problem, how to work with your team effectively, and how to contribute to open source in the kind of work that you're doing. And for me, it's important in the second edition of the book that it's not just about how do I go fast? How do I get down to the lowest level of my caches and make the processing go as fast as possible? How do I push data around my bus as quickly as possible? I've covered more on profiling the code so we can find where the slow things are so that you can make an appropriate decision to invest your poor resource of time into the one thing that will make everything better so that you can make a more optimal decision. But then stepping back from there and then considering the question, well, how can I be a more highly performant programmer in general? What is it that I have to do? Well, probably I need to write more tests, think about my code, communicate with my team. And these are things that I cover in my training now as I think more about this. And so I've gone in this interesting evolution from 10 years ago. It was all about exploiting CUDA down to the lowest possible level, make the physics code go as fast as possible, through to now. And I'm sitting back and going, well, how much of this do I need to work out on paper before I write a single line of code, such that when I'm writing code, really I'm expressing a reasonably well-developed idea that I've thought through on paper, and I'm just typing it in, and probably it works reasonably well first time, and then I'm quickly moving through the space of the uncertainty that I'm facing in whichever research domain I'm working on to get to something that kind of works. And I try to work very hard to stop doing that, hack away at a crazy idea and actually think more about it, because I've realized that makes me more performant as a research developer overall. And that's something we've tried to push into the book as part of our 20-year plus in our career wisdom. We're becoming a little bit older in this domain now. And it turns out going slower, thinking about it, thinking through the uncertainties and the problems, and then working efficiently is probably just a better way through this kind of thing. It gets me to coffee time and to the pub quicker, and that makes my life happier. So these things are good for me.
I wish you had said chai time.
I mean, chai time, yes, of course. But for me, it's coffee time and pub time. Those are the things that push my buttons.
So the audience will know if they see a jump cut now. That's the reason. But for the Zoomers that are probably wondering, I'd like to mention that there was no TensorFlow until 2015. And 480 comes from an era where they didn't have TI cards, I believe. So 480 used to be the flagship card, I remember, if I remember correctly.
Yeah. Yes, the GTX 480 was one of the early cards that had big heat pipes, and it looked like an H.R. Geiger design from the film Alien. And it was amazing. And there's a photo on my blog where I've taken this photo of these heat pipes, and it looked really cool. Now, of course, it doesn't look cool at all. It just looks a little bit silly because it's kind of a small card, and it's only got heat pipes on one side of it, and it just runs off of a conventional power supply unit, and it doesn't require custom cooling. It's certainly no TI cards back then. I mean, this was back when everything was, I think there was no... was 32-bit only, so there were questions about accuracy of the 32-bit processors. They were slow getting data. I mean, it's one of the reasons why I'm less interested in GPUs as a general technology, and that's a little bit heretical for some people, but it's a position that I take. I'm a bit less interested because there's a big question about how do I get my data from my hard drive, my storage systems, onto a computer and then into a GPU. And if you're dealing with large streaming video and you've got a high bandwidth pipe and you can get it all the way through to do your image recognition, brilliant. But most people don't have that. Most people have data in a database that they need to pull in, they need to pre-process. They've then got gigabytes worth of data, but more gigabytes than fits into a GPU, so they don't have to then block it up, pass it down a pipe that's not the fastest pipe. It's pretty fast now, but not the fastest pipe. Do their processing and then get an answer back into the CPU so they can decide to push that data somewhere else. And for me, with the kinds of problems that I deal with, often putting it onto a GPU doesn't offer benefits. You might get one part of the process working faster, but the general interactive part of that process, for me, with my kinds of problems, tends to work better on a CPU. So although GPUs are amazing, they do go very fast. They give us a lot of power, and perhaps I was slightly burnt by working in the early ages of this, when they were very specialized and you had to work very hard to get any good performance out of them. And you got great performance when you did it, but it was a lot of work. And now a lot of this comes for free. Also, I do not feel compromised in any way by not being dependent on GPU technology. I feel a bit more general in where my solutions run and in the deployment platforms that can go behind them. I feel less tied into any one provider, and that works for me. Also, most of my stuff runs on my laptop just fine with my i7 cores, and hey, that works for many of the problems that I work on for my clients.
That's fascinating. We'll talk about your projects in a bit, but this question will allow me to transition into another thing that you've been
Please.
working on, which is teaching and conducting so many training sessions and even PyData sessions. Who do you think the book is for? Because newbie, especially, first they feel intimidated because I've never heard of Number. Should I pick this book up? And secondly, the other side is over engineering stuff. So you end up literally profiling every single line of code. Where's the line, and who is this book for?
Right, that's an interesting question. With the book and with my public talks and with the training that I run, I've been trying to redefine my thinking, to go from, I think this is important and I'm going to tell you this is important and you should pay attention, through to, why is it important? Why should you pay attention to me and to this subject, right? Why should you switch on to this? And so I'm actually working on trying to re-describe my courses at the moment. So this question of why is actually very important right now, like literally this week. So why is the high performance content interesting? Well, I think the simple answer is, and it falls back on why did I give the talk that I gave on higher performance Python at EuroPython this weekend. And the reason I gave a talk focused on pandas and not focused on technologies like Rapids, partly Intel SDC or other technologies like Modin and Vakes that can make my pandas code go faster, is that if you already know pandas, you're already using it, it's in your workflow, your colleagues have it, you're going to get more bang for your buck, more effort for the time that you spend by just using pandas more efficiently. And it would be great to adopt a new technology, and some technologies give us a 10x boost in our productivity. And if our data sets are large, it makes sense to do that. But if our data set isn't 10x bigger or 100x bigger, but it's maybe 2x bigger than our RAM, given what we know at the moment, and we can squeeze that data down a little bit of massaging, not losing any important information, and we keep it on our laptops, and we can do it that hour, and we can carry on. And we haven't got a new, slightly different system that runs almost the same as pandas, but isn't quite pandas, because PySpark looks a bit like pandas, but it isn't. The execution model is quite different. Dask looks like pandas, but it isn't. It's got a different delayed execution model. Vakes presents a similar interface to pandas, but it isn't pandas. It's a different implementation. Modin sits on top of pandas, but it has its own limitations. So all of these things require you to have a different mental model. If your data set's big enough and it makes sense, sure, take the time to learn the new system, the bugs, the different behaviors, and the better expressive power. So you get some wins and you get some costs behind it, and you have to make that judgment. But a lot of the time, we can just go further with the tool that we've got. So why do I care about teaching things like higher performance? Well, I want to do the same kind of work on the machine that I've got at the moment. That's the blunt, simple reason. I don't want to have to figure out how Spark works. I've actually done Spark in the past. It's brilliant if you've got a huge data set. So many companies have adopted Spark because it's a great scalability tool, but the data set didn't really need it. And so you end up with a system that makes you, in my opinion, 10 times slower without the 10 to 1,000 times advantage of what it could offer if it really had the data behind it that you need. Whereas a lot of the data sets that I use, they come out of one database. They fit onto one machine. Maybe you need 64 gigabytes of RAM rather than 32, but you don't need terabytes and terabytes worth of equivalent RAM storage and working space. You can just do it on one big machine, or even often one small machine, because a lot of these data sets, they fit on a USB stick. They're just not even that big. And if you think a little bit about the problem, you can do it all interactively, very quickly, locally, and then you can get to your answers quickly. So for me, yes, high performance is all about how do I, and maybe it's because I've gotten old and a bit lazy and I'm a bit of a laggard and I don't want to keep learning all the new things all the time because there are so many new things. I just want to get my answers really quickly on the machine in front of me. And, then that way I get to coffee time and pub time quicker, and that makes me happy. And so these are the things that make me happy. So I try to squeeze things down. So yeah, that's why I think high performance is important. Certainly with the book. How do I find the things that are causing me the bottleneck? And when I teach this in my class, I always have students who say, oh yeah, I spent time, I optimized this, I optimized this, I optimized this, but then my code, it just still had this problem. And then I used the profiling that you showed me, and it turns out there was this other thing that was the problem. And then that was like a 2-line fix, and then everything else was quick anyway, and I didn't need to do the other work. And I think, yeah, the reason I teach this is because I've done exactly that. And I've done exactly that more than once myself. I've learned that if I try to guess where the slow thing is, I always get it wrong. I have to go and measure it. You just get your tape measure, measure out how long this thing takes to run. And if I measure it, then I have an absolute measurement rather than a guess that's from my head based on some assumptions, which are probably wrong because I'm a human and I make wrong assumptions. So if I go and figure out what's slow, then I can choose the best good choice faster technology, or maybe even go from a list to a dictionary and just get faster lookups, because it turns out I didn't need a GPU after all. I just needed to have an appropriate algorithm sitting behind a good data structure in which to represent the thing that is my true bottleneck. And then for the current design of my system, this thing goes much faster. So yes, that's the point that I tried to make on the high performance course.
And I think that's one of the first chapters in the book as well, where you just talk about lists versus tuples and dicts versus. I might be missing the subheading. But...
No, you're right. The first couple of chapters look at fundamentals of Python with how lists and dictionaries and sets are represented. And then it goes straight on into profiling, because Misha and I agreed, yes, everything else is brilliant, but there's no point doing everything else if you don't know where the slow thing is. So get a good fundamental model of how Python works in the first couple of chapters, and then look next at doing your profiling to understand what's slow, both in terms of CPU and in terms of memory. So understanding where perhaps you're just using lots of RAM, and if you get rid of that large consumption, things might go faster because there's less bits flying around. And this notion that data has mass and data has inertia, and moving gigabytes is slower than moving kilobytes. So if you can shrink down your RAM because you know what's big, or if you can find the bit that takes too long and you can shrink that down, then things are going to be better. And then we move on to the wonderful world of compiling and multi-core and maybe even clusters, although we generally advise against using clusters because many problems with a little bit of thought can be shrunk down to fit onto one machine. Maybe a big machine with 64 cores and many hundreds of gigabytes of RAM, but still one machine, rather than a clustered solution which has latency and downtime and synchronization problems and a whole bunch of other things that are wonderfully fascinating, but an easy way to lose hours or days of productivity. And for me, again, I'm a little bit older now. I want what I want on one machine, so I can sit here with my coffee, code up, and get my answer.
You mentioned coffee again. That'll be another jump edit.
You're not a coffee fan, then, I take it.
I'm on Team Chai. you might be able to catch me drinking some other stuff at night, but not on the show.
Oh, I'm nearly getting to the point of roasting my own green beans, so I really quite care about my coffee.
Okay. But I think I picked this up from one of your talks. For the audience, please do check out all of Ian's talk. They're amazing. The end goal is for you to be performant and not your programs to be performant. I think that's one fine trade-off that new developers, by which I mean people like me who just copy code from Stack Overflow, overlook, and just when we learn about something, we literally time it across every single function, and then we realize that wasn't the end goal.
Yes, absolutely. So that's actually one of the additions that I'm quite proud of in the book, where I sat back and thought, well, this book is all about getting to solutions faster, but the biggest bottleneck in this process has to be me, because I'm the one who expresses the code. So if I have the wrong mental model or I have the wrong toolkit behind me, I'm going to write code that isn't the best code for this particular task. We've always got a time and effort trade-off. We can't use the fundamentally best things on the planet all the time because there'll be too many things to go and learn. So we have to make some trades. But there are some really good practices that I can follow that many data scientists don't follow because they've never been taught them. And if I stop and I think, and I go a bit slower, and so I put some more timing in up front thinking about a problem, maybe the solution flows faster afterwards. Maybe I can structure a solution so that there's less rework, less refactoring of my work. Maybe I can think through a problem from what I think I've got at the beginning through to what I know I need at the end, and realize that actually the thing that I need at the end means that I don't need all this stuff. I just need a little bit of it. And in which case the solution is quite simple, perhaps, but it's only by thinking all through that we get to that. So yes, I've written this section, which includes a little bit a note on how to get the joy back into your work. Because also by being in the domain being in the domain of computing in general for 20 years, and with a family and an active life, there have been highs and lows in life. There have been highs and lows in my life, and my co-author's life, and my friends and family around me. And some of those times, these things are quite draining, and this can have an impact on our work, and they can drag us down. And then it's worth sometimes sitting back and reflecting, hey, actually, I am pretty good at what I do. I've learned a lot along the way. I've learned some really good practices. I know how to do some of these things. And there are some practices that I can undertake to just enjoy the work that I'm doing. So I've had to remind myself at times, hey, there's all this cool stuff out there. You don't just have to use the things that you know are actually pretty good for the job. Sometimes it's worth wandering off and playing with the new cool toys and watching how they break, because sometimes they break in amusing ways and sometimes they work really well. But it's nice to have that playtime. And there was kind of a point a couple of years ago I had to remind myself, Have that playtime. Playtime is important. We can't always all do playtime, but there are times when you sit back and you realize you've been exploiting your knowledge for so long, you've kind of forgotten to just go and play and have fun. And so that's also in one of those early chapters, just trying to reflect on what it means to be in the domain for 20 years. And maybe it's worth trying to be human. Stop, slow down, think about things, use a pen and paper. Pen and paper is a very powerful tool, and then think of good solutions and good ways through to the answers that we're after.
Okay. Over the years, you've also done so many training sessions, so many teaching sessions. I think moreconsulting.com would be the place for the audience if they'd like to get in touch with you. That's spelled morconsulting.com. What are some of the things that you've learned after conducting so many of these sessions, and what sort of sessions do you generally conduct?
Right, and so I was really intrigued when you suggested you might ask me about this, because thinking about what is it that I've learned via teaching? Wow, that's kind of interesting, and so I think my best answer there is it's difficult to explain why things are valuable if you lack the context to appreciate it. And so I've been doing this for 20 odd years. That makes me pretty experienced. There are people who've been doing this for longer, of course. And then if someone who's been doing this longer tells me, Ian, don't do it that way, do it this way. I'll be like, yeah, but this has served me pretty well for quite a long amount of time. But it probably turns out actually they know better. And translating that bit of context down the line is quite difficult. And so I've been giving public talks since 2011. So I put lots of volunteer time into the community to give back in exchange for all of the wonderful tools that others have volunteered that I've been able to use. I'm happy with that trade. But it means that I've encountered a lot of problems and bugs and interesting ideas along the way. And I try to explain this in my talks, in the book, and in the private trainings that I run. And so I'll give you 3 examples. So I run 3 different courses, and I'll give you an example from each of them, because these are on my mind as I think about my courses at the moment. So I mentioned it's difficult to explain why valuable things are valuable if you lack the context. I run a course called Successful Data Science Projects. I run this course because I've had a mixture of successful and failed data science
I'm
projects.
sorry, people can sign up for this course through your website?
Absolutely. So, yes, Sam, that's a good point. Thank you. You've mentioned my More Consulting website. Actually, most of this is hosted on my blog, which is ianozsvald.com. And I've got a training page on there, and that links to these courses.
Please scroll to the show notes and find those links if you'd like.
Perfect. Thank you very much. So yes, ianozsvald.com, and you'll find the training there. So one of the courses is this success training, so successful data science projects. I created that because I've had a mixture of successful projects and failed projects in 20 years. And of course we have. We all do if we're working in this domain, particularly on more researchy projects. Failures are really frustrating. I don't mind getting something wrong once, but when I realize the same thing has bitten me 3 times over the years, that's not so cool. I should be smarter than this. So how do I get past these failures? And one of my ways of doing this is encoding it via teaching and sharing the lessons and getting the students to share their experiences back. And on the description page for this, it says, an ideal student for this course is someone who's had failure in their data science projects before. Because I've had students come along who are in their first year. They're looking to invest in themselves. They come on the success course, and that's brilliant. I cover a whole bunch of things. How do we de-risk projects? How do we design a project with a good flow behind it? How do we think about who the stakeholders are and how we communicate to them? And particularly, how do we lay out a project specification? So our uncertainties, the things that we need to do, the things we should de-risk, and then some milestones behind it. And they say, this is all great, but why isn't it better just to hack faster and make more machine learning? It's like, right, here's the thing. You haven't had the failure that's made you sit back and go, I should have had a plan in the first place. I didn't have a plan. I needed a plan, because it turns out we need a plan. But if you lack that context, it's hard to see why you might need a plan rather than just doing the next Haggle competition, because the data's laid out in the right format. We know what the end goal is. We know what we need to do. We know what the deadline is, and it kind of all fits together nicely. And so that success course is all about, hey, assuming you've had a failure, at least one failure, then we can go through this process to try to figure out what that failure was, what my failures have been, and how we get past those into the future. So my software engineering course there, that's all about the simple thesis. Many data scientists came out of academia and they never learned good software engineering practices. They get into a company, they write their first notebooks. Brilliant, they've solved a problem. The company says, hey, deploy that solution. And then the data scientist says, deploy? well, that's not my job. I've written a notebook, right? I've done the clever machine learning. Someone else can do that bit. But it turns out they've got to do that bit. And the software engineers are in the next room. And the software engineers say, oh, Kubernetes and Docker and deployment and continuous integration. The data scientist says, I don't understand those words and I don't really care about them. But it turns out they've got to communicate. So that course is about bringing the data scientists closer to the software engineers to make them more relevant to the organization overall. And then in the class, I say, right, let's start with a bad notebook. And then you tell me what's wrong in this notebook. We're going to do a code critique as if you were code reviewing your colleague. And some of them say, I've never really done this, but I kind of recognize this code. So, yeah, this code's awful. You should never write code this way, but that's why we're here. So we identify the bad code and we refactor it. And then we write some unit tests. And they say, yeah, unit tests, they're all fine, right? But they don't make me go any faster. And then you have some people in the room say, actually, I've been like doing this for 5 years. And there have been times when I committed code that looked right, but actually it would have got me fired. And it was the unit test that saved me from getting fired. They're really valuable. And they're not just valuable in that situation. They give me trust in my code. They give me trust when somebody upgrades something. The math libraries get upgraded in my Anaconda distribution, or my operating system has a significant upgrade and some of the math libraries provided by the operating system are changed. Or I'm developing on Intel, but deploying onto ARM. I need to know that the system works the same. And so I try to impress this upon people. But if they're in their first year, they haven't got that bit of context. And I find that it's quite a tricky one here. How do I explain? This is really important. This will help you not get fired in the future, and it will also help you develop code quicker in a more trustworthy fashion. And then the final one, I've mentioned the higher performance. I've got a bunch of skills, and I want my solutions to scale up some more. I want to process more data. Suddenly, I've got 10x more data. What do I do? Well, I could learn a bigger solution. I could switch to Spark. I could employ a Spark engineer, or I could figure out how to shrink my data down, use multi-core, and then go faster in the same bit of tooling. So the same day, I'm more productive than I would otherwise normally be. And so I think these are the bits that are really important to me. And it's that, this is just reflecting on that question, what have I learned? It's really hard to share that context with someone who hasn't gone and really made a mess of things a couple of times to make them realize that these things, they're important because they're really important. Sanyam, what's your position on testing, unit testing, and refactoring your code? How would you see those things?
For the first time, when I heard that you need to do tests, I realized, okay, I was in university. What are you talking about? Test myself, test my code. What does that mean? And then through the Fast AI course, I learned about unit tests and this amazing world. I've gone to the extent of overdoing it many times, but I try to be conscious because I play a lot with deep learning code, and it's not always easy to put unit tests everywhere. But then I've realized that some functions, like you mentioned, just checking the libraries, just checking if the data is going in there so that I don't get those annoying errors of size tensor mismatch.
Yeah.
I guess through the failures I've learned, and that was only because I've hit those roadblocks like you mentioned.
That's it. And it's that context again. Now that I've gone through those failures, I recognize that, hey, actually, some of these things are really painful at times. And for me, it's always, I don't mind making a mistake once, but I just get really tired when I make a mistake a second or third time. If it's the same mistake, right? It's kind of boring. And so one thing I've realized with unit testing, as a free bit of advice to everyone listening, unit testing, if you've got a bit of processing code coming up, you're going to read in some data, process it and transform it, and then use it later on. And it's non-trivial. It's more than one line of code. If you write some unit tests where you write, given this input, I want this output, and then I'm going to call this function that I haven't written yet, and you write a few of these tests, you run your tests, they fail because I haven't written the function, and then you go and write the function that implements these tests, so that's a test-driven development style, then you will find that you've spec'd out the interface for this processing function that you had in mind, but you hadn't really thought it through, and probably by spelling out, given this input, I want this output, but with this variant input, I want this slightly different output, then you'll figure out what the call signature should be, and then the implementation should flow. You implement it, you run your tests, your test passed, happy days, get on with the next thing. It feels a bit boring and slow to go that process, but it turns out I found, at least in my case, I found that I developed that kind of code faster and more reliably by working in a test-driven development methodology. If I'm doing research code to understand some novel data, I can't apply that. I have to go and dive into the data and figure out what I've got. And if I'm writing machine learning solutions from scratch, I can't use that approach. But if I'm doing that, loading in the data, processing it and transforming it stage, I just write tests first of all. My life is easier. I get to coffee quicker, or tea if we're tea lovers, and we get to break time quicker. And that's the important thing, of course. So
I guess,
free bit of advice.
I'd be in my developer life, I'd be at the stage where I almost get frustrated of misremembering which Stack Overflow answer was useful. So I'm at that part and not at the stage where I get just frustrated of seeing that error for the second time. But I guess, like you said, as your intuition builds, you would just know that you need to put a test in there because this part or this section where you're loading in the data is prone to some faults.
Yeah, well, as soon as your math gets a little bit complicated, you have multiple columns going into your logic, or you have regular expressions. As soon as you've got those things, you should write a test. It's a simple guide. Have you come across unit test coverage testing? So the coverage from Ned Batchelder. Another tip then. So coverage, when you run coverage, it runs your unit tests. And for every one of your unit tests, it calls into your code. It records which lines of your code you've tested.
Okay.
And then at the end of running all the unit tests, it gives you a report saying, oh, you ran these lines, but you didn't run these 30% of lines in these modules. And so it's basically giving you a big finger-pointing exercise saying, you tested this, brilliant, this bit, you didn't test, you're an idiot. You probably want to go and test it. Now, you could fill those in to get to 100% coverage. If those functions are they're really boring, you know they work, or they have very low impact on your project, you probably don't want to invest the time testing them. If it turns out a couple of those functions are actually critical to the rest of your work, and they're complicated, and you haven't tested them, then you know exactly where to spend your time to be a performant developer, putting some tests around these and making sure they work as you want now and in the future when you upgrade your libraries or expand your system or change your code, such that you get what you want out of it and you can trust it. So yeah, a combination of unit tests and some coverage and a little bit of thinking about, actually, do I need to test this? Does it matter? Do I get a good bang for my buck by spending my time here, or should I be doing something else? And yes, that is intuition. But the coverage tool I found is very useful for helping point me in the right direction.
And I believe that would come with intuition as you go through doing so many projects, and the failures, like you said, those are important.
Yeah, absolutely. Well, I mean, all of this, right, is it's a mixture of our hopes and desires are tempered by our failures and frustrations, and then finding a way to stay positive and not get too dragged down at times and then positive again. These tools help me stay more consistent, sort of bobbling somewhere in between the two. And when things go wrong, great, I see it as a learning opportunity now. You mentioned remembering to keep track of Stack Overflow posts. So I've got a bunch of Google Docs where I record the things that are important to me. I've got GitHub command or Git commands going back like a decade, and they're quite indecipherable because Git is indecipherable, and that's a bit frustrating. I've just started recently a new GitHub open project just for me. It's called Notes to Self, and it's for me. It's open so anyone could read it, but it's for me, where all those matplotlib one-liners that help me, I've put a bit of context around them. So they're a little bit like a gist, a bit like a wiki, but it's a page written for me, and it's actually a page and a couple of modules of code coming soon, of all the things that I've done about at least 10 times, and I'm bored of going and searching for them every time. All of those, how do I turn off the two different axes plots, and how do I change the grid styles on Matplotlib? How do I tune my coverage and PyTest parameters? How do I make sure I've got a few things in there with pandas. Some notes on how do I merge effectively and then debug the merges to make sure I haven't lost data in the process. Just because once you've done it 10 times, it's really boring having to do it an 11th time. So I'm writing some public notes to myself. Partly they're public in the hope that someone says, Ian, that's kind of a good solution, but there's an even better solution. That would be even better for me. But hey, it's public just to share it to others, and partly so that I have to write it legibly. I can't just make bad quality notes because hey, it's public. It's on my public account, and that's an investment in my education for the future as well. So that may be a tip, an idea you'd like to try and experiment. Make some public notes around some of these things. It clarifies my thinking, and maybe it helps somebody else.
I really hope you converted it to a blog post. I've really loved all of your blog posts. For the audience, it's on, again, your website, ianozsvald.com. Please do read them.
Thank you very much.
So in one of your talks, you mentioned that you work at the intersection of engineering and data science. You called yourself engineer data scientist. what are the best data science practices that you've learned over these years? If you could, maybe you mentioned an interesting project that you've been working on recently. Maybe you could quote that and connect the dots.
Okay. Oh, interesting. So I'll tell you some big picture thoughts first of all, and partly this comes out of what I cover in my training, but I can give you the high level super easily. So one of them in data science projects, and I think it applies to research, so not just data science or AI, but research in general, is know where you're going. So it's quite easy to start a project, and in the data science boom that we've had over the last 7 years, there was a lot of money thrown at data science, where the goal was to make lots of money and become big and popular and make an amazing thing in a company, but without necessarily knowing why we were doing it and where we were going. So I've learned to make a project specification document. And actually, I've got some notes on this, a couple of bullet point notes on my notes to self repo on GitHub, just to remind myself about those key points. And some of the key points are, why is this valuable? What actually is this thing genuinely valuable? Is it, maybe it's a vanity project somebody came up with. Maybe it's a brilliant idea, but it turns out the data doesn't exist behind it. So why is it actually valuable? Why will it move the dial for my client? Do I understand the risks? If my client says, we need to process this data, it contains loads of insight, we've never looked at it, and we've had different people typing in the data for the last 5 years, but I promise you it's full of gold. I know they're lying. It's really unfortunate. They mean well, but they're lying. If no one's looked at this data, it's full of rubbish. Might be full of gold, but it's probably full of rubbish. And so I know straight away that the risks on this project have gone up. So I need to de-risk that project. So this project specification is a way of laying out these things. This is the goal of the project. These things are important. These are the risks we've identified so far. This is my mechanism for understanding these risks and de-risking them. So if I think this thing might kill the entire project, well, I better go and look into it first of all. And these things, they're pretty important, but they're kind of second tier, so fine. They come a bit lower down the priority list. But if any of these things are false, the project is dead, well, fine. There's no point developing a prototype machine learning model. I need to go and figure these things out. Even if this means walking around a couple of buildings, finding various people and asking them face to face if certain things are true or if certain data is available. Because I've worked on projects for 3 months, where after 3 months, I still had people saying, oh, you need that other bit of data, not all the other 30 bits, but that other bit. Oh, go and talk to that person over there. I'm sure they've got it. And they've also got a spreadsheet with a few lines of critical data, but not all the data. And I've gone round and round in circles. And in the end, you can't find the data. So it turns out that entire project was rubbish because we couldn't get the data in the organization. But it took months to figure this out. That was the biggest risk in the project, not the machine learning. So one of the things is de-risking a project, but coming up with a specification a few pages long just to describe it.
In Kaggle terms, it'll be EDA, doing data exploration before actually doing modeling, if I may.
Right. So that's absolutely part of it. And actually, I teach that EDA should be a part of that de-risking process, because that exploratory phase, what have I got? Does it meet the expectations that I've gathered from my colleagues? And does it support the questions that I need to ask, the things that are valuable for the project? Well, hey, we can do some exploratory work. We can draw some brilliant diagrams. We can even use machine learning tools like Dabble, DABL, which does some of that exploratory analysis automatically with automated machine learning from a tool like scikit-learn to give us the diagrams and the exploration that we need whilst we go and have break time. And that's brilliant, right? And so these things are really important, but these go into that document as far as I'm concerned, because they're all part of this early process. And when you've got through this bit, then of course we can go off and do the machine learning. When we're satisfied, it's worth investing our time that way, because it would not be performant as a developer, as a researcher, to go and solve the wrong problem. That would be the wrong thing to go and do. We have to make sure we're solving the right problem. So solving the right problem, that's incredibly important. Project specifications, I think, are invaluable there. Just a short document written by me, for me, to share with my colleagues. Nothing too onerous, but something that makes me happy that I'm solving the right thing. And then other tools like, well, writing unit tests. I mean, that's just... it's not boring at all. In fact, unit tests are amazing. I should just get really excited about unit tests. Everyone, unit tests are amazing. Write loads of unit tests. Unit tests, PyTest, using coverage, maybe looking at Dave McKeever's hypothesis library. These are nice ways to make sure that our code does what we want it to do, so that we're not held up on silly bugs and silly things that break our concentration and make us less performant, so that we can get on with the things that require the real cognitive process and they let us get on with the really interesting work. I think communicating with our colleagues, so visual communication, turns out it's really hard to convince people by just giving them lots of details. We have to tell a story, we have to show nice diagrams. So if we show nice diagrams, they have to be correct, they should include some estimate of uncertainty, they should be well labeled, axis titles, axis labels, good units, it should be the right data going into it, we have to do it properly. But if we do that and we present the right diagram, then rather than saying, oh, I got a 0.0003% improvement in my model, instead showing, look, this is why if we adopt model A, we make £1 million more than if we adopt model B. And, here's the diagram with the deciles broken out. And everyone goes, oh, right, I get that. Right, we'll get our bonuses. Brilliant. We should do that one. And so that visual communication is incredibly important. And behind that, explaining the underlying models. So if we have I've had a number of cases with clients where I've had colleagues, so I go in, one of my roles is to go in as a coach into teams, and then I work with a team that lacks a senior, maybe it's a younger team that's grown up quickly, and they need some senior advice. So I go in and I help the team, and I find often that people are trying to ship black box models onto their internal clients. So some department that has no machine learning, maybe they're Excel warriors, but they've got no machine learning, and then they're being told by somebody else, some young upstart who's got their data science degree in the last 5 years, and they're saying, use this XGBoost or TensorFlow or whatever model, it's amazing, but not justifying why it's amazing. And then I find, well, okay, fine, let's present these inputs, give us these kind of outputs. These things are the features that are really important. These are the ones that actually push the judgment, the probabilities in a certain way. So let's pull those out. Let's look at our underlying data and explain visually how many of these we have, how many of these we don't have, where in our space we are certain of our predictions and where we're not certain of our predictions, and what the major relationships are in there. All of a sudden, the internal client goes, oh, you understand the data. I understand what the model's doing. Brilliant. Let's just use it. And so that visual communication I found is so much more important than trying to squeak out another 1% improvement in the quality of my model. That can become very important later on. But if you can't ship the first version internally, getting incremental improvements in accuracy metrics or whatever, that won't cut it. Getting the internal customer on side by giving them trust in your system, explaining it, explaining where the certainty is and where the uncertainty is, because that's, the humans know that some of the data is good and some of the data is bad. They know they understand some of the customers more and some customers less. So they don't want to hear the model making confident predictions about things that they know are rubbish. So visual communication around all of that I found is incredibly important. So yes, I think top tips for me: good project specification, so I de-risk the thing that I'm working on. Good working practices like refactoring and writing unit tests and explaining visually the models to my end client so that they understand and trust. They trust that I understand their domain, the things that work and the things that don't work, and I'm honest about it. And at which point, there probably aren't any strong blockers a lot of the time. And then I can get things shipped. The client sees value. The client comes back and says, hey, we want 10% more accuracy on this because we're making money. We want to make more money out of it. And then you say, well, okay, now I can no longer use my regular decision tree and my simple bit of pre-processing. Now we need to go GPUs and crazy. And then the project gets even more interesting. But you have to go through those incremental stages. I think that's really important, going in those stages.
I'm sure, Ian, you worked across so many rich projects. You collected this knowledge, but for someone who's just starting out, how can they sort of fast track through picking these ideas up? Because I'm sure there's it comes to knowledge, but is there a fast track route to it?
So no, there's no fast track, but there's ways of solving some of the uncertainties quicker, I think. And there are some techniques that are not discussed in the data science community or in many communities, which are important to improving the likelihood that you get a career and that you accelerate quickly. So if you don't have a lot of experience with machine learning or exploratory data analysis or pandas or R, the equivalent, whatever, any of these toolings to turn raw data into something useful, go to Kaggle. Maybe compete, but more importantly, go and read the code that's been put up by other people that's well voted. Figure out how they've written the code and figure out what they're visually communicating, and then replicate it. Work on your own projects, fork their projects, or go and take your own projects. I'm a huge believer in getting some government open data in the European Union. Here in the UK, we've got loads of open data. We can get good open data, and then we can do things with it. So tell a story that no one's ever seen before with this data. As soon as you start telling a story, you realize that your matplotlib skills are bad. You can't quite tell that story. The data's not as good as you want. brilliant, you've discovered uncertainty in our data, and that's just endemic in the real world. So we have to do something about it, figure out what you want to do about it, and tell a story around that. So that gets you practicing with real data, and Kaggle gives you a brilliant place full of scripts, full of interesting challenges, and full of people in the forum who can give you good guidance. That's a great place to go. Now, another step is, well, I've done some of this and I'm applying for a job, but I'm not getting a job. Why am I not getting a job? Well, if you're going through the front door of any recruitment process into a large organization, you are competing with another 1,000 people who graduated recently from various data science boot camps. That's probably the wrong way to go. You don't want to go through the front door on these things. So you want to go via a back door. And a back door might be attending, say, a hackathon where, people from the company are interested in are attending and joining their projects. As soon as you get to know the people behind these projects, the internal people, if they like you, if they rate you even a little bit, and they think, hey, actually, you're okay as a person, and it's just going to sound horrible, but I'll put it very simply. If you're okay as a person, you're better than 99% of the people going through the front door to most of these organizations, because so many people come in and they don't really know if they want to work there. They're just playing a numbers game and they're throwing their CVs everywhere. You're being very diligent. You're a lovely person. You've worked very hard, but you look the same as them when your bit of paper comes to the front door, just the same as all of the others. You don't want to look like them. You want to look different. So you turn up and you may not know a lot. You may be unconfident. You may not have very strong communication skills at this point, but this is fine. You start working on a hackathon, physically or probably right now in the pandemic virtually, but you work with some people. They don't really get to meet you. Maybe they can't even meet you physically. They can't judge you very well, but they think, all right, this person seems to be all right. You could be brilliant, but you can't meet them. You haven't developed a deep relationship, but they think, okay, this person's probably all right. Already you're well ahead of the pack at this point. If you can then say, oh yeah, and I worked with those internal developers and we wrote a test. I wrote a unit test. Well, again, you're ahead of 99% of the applicants because you've written a unit test. And we developed something on the continuous integration server and we actually made some graphical output and we explained it. Well, brilliant, please come to me. I'll interview at that point because you're ahead of so many other people who are early on in this race. And if you know those internal people, they'll refer you to the internal recruiters and they will pass you on with a good word. So that gets you ahead of the pack again. If you can then say, oh, and not just here's my cover letter saying I'm a nice person, but here's my GitHub account and here's my Kaggle account where I've got some scripts, I've written some code, I've maybe contributed a little fix to pandas. And that fix could be a documentation fix, could be as simple as that. But I've learned something about the whole open source contribution process, the continuous integration servers, their unit test process. I understand those mechanics. You're blazing a huge, great big light behind you saying, I'm diligent, I'm interesting, I'm switched on, I've done something useful. You look amazing at this point. Whereas most other people going in the front door just look like a bit of A4 paper with a CV on it and no way to differentiate themselves. And so all of a sudden, and I say this trying to be really clear, right? You might be really unconfident and really just not very sure about any of this. Don't worry about any of that. What matters is you've done some interesting bits, demonstrated you've got some skills, you can write some code, you can do some visual communication, you've met some people, that means you've got good verbal skills. Turns out that counts for a lot in large organizations. And then ask people to push on some of these things internally, and that will unlock so many more doors than just sending out 1,000 CVs to different organizations. I would always recommend never do that. Always try to go via some kind of back mechanism. In the forums of Scikit-learn and Pandas, find the interesting people in the organizations that you think are interesting. Ask them a question, show them something you've done, engage them in a conversation, say you're interested in the organization. Maybe they'll give you an introduction. That's a much better way to go than via any front door application process.
That's amazing advice. I'd also like to drop a plug. I'm part of a group that's running a Chai EDA bi-weekly session where we pick a data set, people get to do EDA, and then we critique each other's work. And if they like, they can present it on Chai Time Data Science. So if anyone from the audience would like to join that.
Right. And so this is exactly the right kind of community for this. And so we do this here in London with the PyData London meetup. There I've got 11,000 members. And okay, we're not meeting at the moment because of the pandemic, but typically we would have 200 people in the room discussing data science and then have a couple of great presentations. And then we go to the pub afterwards. We have continued good conversation. And there'll be so many beginners coming into that community and saying, oh, everyone around here, they're so impressive. And I haven't done a lot of those. You realize, of course, everyone here started in that position some years ago or some months ago in some cases. Here's a top tip. Go and find a speaker, Ask if you can buy them a cup of tea or a beer or a slice of cake. Do something nice for the speaker. Just say thank you to them. Engage them in conversation. And all of a sudden, you're talking to someone who's got some serious experience. That's brilliant. You can tell them something you've did. Maybe they give you a bit of a critique, just like you were talking about there, Sam. And then that critique is incredibly important. You start that conversation, and then you go from being a person on the edge of the crowd to someone who's inside the crowd talking to everybody else. And be it virtual or be it physically done. That's just stepping forwards and engaging in conversation is incredibly important. So I think actually, yeah, if I tried to give you the one tip, it would be engage other people in conversation. At any of these events, join these kind of groups that Sanyam runs. This is exactly the kind of thing that you should be getting involved in. And then have conversations and also, say what it is that you're after, say what it is that you've got that you can help out somebody else with, be a nice person in the community, give and take, and that will get you a very long way.
And just to add to that, Sarah from Google AI on an earlier interview mentioned that when you're starting out, remember the fact that many important people will open your email. So be a proper communicator. Like Ian opened my email and we had a chance to discuss this on the podcast. So for my final question, I tried to ask a tricky one. I have two for you. Usually these are tricky for my heroes. Which is harder, making good bread or good machine learning pipelines?
So do you ask that because you know that I'm making bread?
Yes.
Right. Okay. So bread making has been my pandemic project. I've gone from starting with a no-knead recipe with not knowing what that even meant and a very gloopy mixture. And it turns out you bake it and you get bread, but the physics made no sense to me. Through to now, I consistently make sourdough breads that I'm pretty sure I could sell in a shop in London. So I'm generally very happy with that. Actually, the one that I baked this morning had a streak of flour through it, and I know how my final folding process, I didn't quite get it right, and it's a little bit intermittent, but...
It failed the unit test.
Well, that's it. In that case, yeah, this was not past quality control, that particular one, but it turns out I changed flour recently, so I changed my experimental process. I didn't change my hydration level to match up to it. I'm learning the chemistry behind this now.
There was a change of frameworks.
How to make good bread. So, well, that's it, right? But you also... We've got to keep life interesting. We've got to keep experimenting. So I'm changing my flour. I'm changing the recipes that I use. I change the seeds that I add into it. And then I change the bake time. I change the Dutch oven. I change the exposure time to get the crisping on the top. Turns out I know a little bit about bread making in a tiny niche domain now. I've learned a bit. So I don't know which one is more difficult. Both are challenging in their own right. I can tell you assuredly that bread making tastes better and smells better. Okay. We get no nice olfactory feedback from our machine learning models, apart from when something's burning, and then that's bad news, right? That's a $2,000 laptop burning away. That's no good at all. Whereas my bread smells amazing and it makes me happy.
That's good to know. Final question: are you a gamer? If you are, your favorite game of all time?
Right. So. No, not really, actually, even though I have these very big headphones on which glow blue. Early in my career, my colleagues and I in the AI research firm, we used to play Wolfenstein later on and Quake. So Quake 2 and then Wolfenstein. This is back when it was difficult to get a 3D graphic card. Some of us had one and some of us didn't. And whoever had the graphics card basically could kill everyone else because they could see further in 3D world. Loads of Castle Wolfenstein. That was amazing. And that was one of my first experiences playing 3D games online. I bought the current machine so I could play the latest version of Doom, which was sort of 3-4 years ago. And that was a really cool experience. Actually, so my partner, she works in Mozilla. She's got an Oculus Quest headset. So I've started VR gaming now. And currently Arizona Sunshine, so running around shooting zombies. That's amazing. Or solving the Room VR. That's being inside a very slow environment where you can be a large character or a small character, and then you get a sense of depth and a little bit of vertigo when the world changes around you, all in VR, untethered. That's kind of amazing. So not a PC gamer, currently a little bit of a VR gamer.
But you have to pick one. You have to pick one game.
Well, actually, honestly, if I tell you what my biggest gameplay is trading my dog, my Springer Spaniel, I've got a working Springer Spaniel, which means she's very intelligent and very driven. She wants to do 8 hours work every day. We're 3 years into that, and I'm continuously refining my current understanding of classical conditioning versus operant conditioning, and the duality of setting up an experiment, some kind of training scenario, where she knows she'll get what she wants at the end of it, if only she learns to do what I want her to do first of all. And then we're getting very good at figuring out, and she's getting very good at gaming me. She's always been good at gaming me. And her persistence is stronger than my patience at times, and we have to learn how to moderate this. So actually, I've got a real world Red Queen problem of me trying to keep up with my very smart dog, and my very smart dog trying to keep up and outsmart me to get what she wants. And actually, that's probably the most engaging game in my world at the moment. So that keeps me happy.
I'm really happy we got to cover reinforcement learning as well on this podcast. Before we end the call, Ian, what would be the best platforms for the audience to connect with you? There's your website, moreconsulting.com as well, and any other platforms you'd like to mention?
Right. So, so More Consulting is my business site, but I confess that's actually quite old. I haven't touched that in a long time because I do all of my work on my blog, ianozsvald.com. So all of my talks are on there. My thoughts are on there. I've got a mailing list that I publish every 2 weeks called My Thoughts and Jobs List that has jobs that I know about in the UK and typically Western Europe ecosystem, mixture of Permi and contract jobs. They're listed on there to help build the PyData community that I'm a part of. And it includes my thoughts and tips, so libraries that I've learned about and videos that I think are really interesting and books that I've been reading. So that's very personal to me, but hey, if you want to come on this journey, then come and join that. You'll find that on my blog. I do use LinkedIn. I'm happy to link in with people if you give me a message to say that you actually know me and you're not just a recruiter trying to hit out to 1,000 people a day. You'll just say hello, mention the podcast, and that'll be brilliant. And Twitter is where I'm semi-active. I actually try to read less Twitter at the moment because it's full of so much angst and stress around the world. But I'm trying to cut down my social media usage. But Twitter is the one place where I also find out about new libraries and new interesting tools for my work. So I moderate my usage there. But yes, please get hold of me, contact me through my blog, read all my articles on there, and reach out on Twitter if you'd like to say hello, and that would be amazing. I'd love to say hello.
I just turned around and looked at your username. It's literally Ian's first name combined with the second name. That's his Twitter username. Apart from that, please find all of the links in the show notes. And thank you so much, Ian, for your time and for all of these amazing insights and for sharing them with the audience.
You're very welcome, Sam. I love talking about these things. Thanks for having me.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.